We're good and welcome to this particular session on we can talk about IoT testing, challenges in the use cases. So the topic itself says that in my talk next after 15 minutes, I'm going to be pretty precise on the challenges. All right, so it would be kind of what is your role into this case. And as we talk about technology, disruptive technologies like think is one of them, and when we had sort of previous sessions like IoT was a bit of involved like in security part, again security concern we talk about. So IoT security concerns are more of focus, big data analytics as well. So IoT based data analytics is more of focus. All right, so in next 10 minutes I'd like to share my views in which like what exactly a bit of IoT is. Well, I know that all of you would have already, like as we are into technology, all of you would have already been into sort of conferences or introduction to disruptive technologies, what exactly IoT is. But though I have met a lot of people who have a similar point of view, what exactly IoT is, which is what I just want to like kind of say. So how many of you believe that IoT is all about controlling your appliances from your smartphone and getting data from them? How many of you believe like that? Or if you have any other definition? Like controlling your devices and controlling tube light and all those parts. If I'm traveling somewhere outside, I can get data from my refrigerator or a certain AC, whether it is switched on or off. So how many believe IoT is all about this part? Okay, so we have certain sort of hands. So well, probably you might not be, all of you might not be pretty much into that part because when we are into industry, we stick to a particular profession into what we are, and a bit less time probably might get into explore a couple of other stuff, that too very deeply. So everybody you meet in India, if somebody has been like 3 to 4 years into industry, everybody knows that yes, IoT is all about controlling your devices from home and all. But frankly speaking, this is just one part of it. Well, it's quite big than that, and broader, the opportunities, the projects, and the things which are there into that. So in next 10 to 15 minutes, I would like to just you people to explore what exactly other phases of IoT is and are, and like how those are going to affect us into currently what we are into, and currently what kind of projects we deal, and what kind of roles we play into IT industry. Okay, so coming back to that, so thinking challenges and use cases. Before that, if we talk about why do we use internet part, like first particular phrase, internet. So we use internet a lot of use cases, like we use internet to gather data information from a lot of websites. We use internet to connect with our friends and family, or professional network, like social networking, you do exchange messages over email, or LinkedIn, Facebook, Twitter, Google+. And we use internet to provide and access some services. You use internet to do online sort of e-commerce, banking, travel management, and entertainment, education, XYZ stuff which we used to do offline. Internet has made that so easy. So probably like those who are very young and pretty new to technology might not know or might not have visualized the power of internet. Somebody who is from 20 years into industry would have seen the entry of internet in India and how it changed everything. So the power of internet is so big, and that big power has created a lot of big industry into a particular last decade. And all of them are not so, most of them are so new, and I hope you believe they are not all of them. There are even, there is even big list. So all the companies which used to, which are currently working into the market, and online companies, to talk about something that we usually come across involving Amazon, Flipkart, or Facebook, Google. All these companies could grow with a very exponential growth rate, and they could attain a huge number of user base in a very short span of time. In fact, so the growth rate is quite even good. I'm not talking about the amount of complete revenue being generated compared to the oil and gas and manufacturing and all those parts. The growth rate part in terms of the time duration and the number of customers they could get, and without putting much of the input, how they could use technology in a smarter way to grow their business. So these companies are quite ahead into that particular perspective. Of these companies, whenever we go to Amazon, we search for I'm searching for a shoe, so I'm creating data about what kind of shoe I'm looking for. If I search for a couple of shoes on Amazon, probably I create data about what is my buying capability, what is my taste, and probably based on a couple of other previous purchases I would have made on Amazon, I create data like what is my buying cycle, how much time I do spend in bargaining things, and after that I do buy products. So they just analyze data, and based on that they do the, making use of data, they keep on showing me advertisement of shoes every now and then. Website I visit on internet till next 2 to 3 days. I hope all of you would have already observed this part, and this is not something new. But you see, these all companies are making use of the data that we humans create, and their business model, the growing model, is all about data-driven model of business. That is the main model how they grow. You talk about Paytm, you do a recharge every. You even might forget about your recharge is going to finish up, but Paytm gives you, remember, when you travel from Bangalore to Pune, a lot of advertisements related to flight back from Pune to Bangalore or hotels in Pune, you keep on getting that. So all these companies can actually make use of data-driven model of business. This quite same way when I go to a particular shop and I go for a shop in offline, I'm talking about, I ask for a shoe. So if I don't like that, a shopkeeper tries to show me another shoe. He tries to understand my likes and dislikes, and he tries to use his intelligence to make a sale anyhow possible. Right? This is what we do. Now, the same way as we create data about what we like and don't like online, the online companies can do so. A shopkeeper might have a limited geography, but online companies cannot have. So these are the reasons why these companies are kind of growing up. They are making use of data-driven model of business because they are in direct contact with the customers who are we humans. When we make use of internet, we create data about them. And now, comparing this sort of domain to oil and gas, manufacturing, automobile you talk about, Maruti Suzuki never knows I'm driving their car and I'm having which kind of problem. Maruti Suzuki never knows that when I start hating them, when I start not using or not recommending their products, or how can they, just after selling the car, how can they make more business out of me? They understand that how do I behave with their product. Offline companies are not much able to make use of data-driven model of business. They cannot create, because the things are not creating data. We create data about what we humans come across every day on internet. All right. IoT is not only about controlling your devices, it's all about making your things, machines, gadgets, physical objects, create data, consume data the way we consume in these certain cases. Making them connect, talk to each other. Saving resources. For example, let's say that I'm traveling to office and my friend is also there, who's also traveling to office probably because of internet or some sort of communication with my friend. I probably might get into single cab or a single car to save the resources of petrol so far. Now we talk about a fan. We have a fan in a room and an AC. Both try to do the same work. They try to maintain the temperature, but they don't talk to each other. They don't talk to each other. So they are blindly trying to do the same thing. No coordination between machines. There are a lot of other use cases into current environment where just making communications between machines, things, using their data, letting them consume data, a lot of resources could be saved. A lot of efficiency could be created. You see, just controlling your tube light from your smartphone or something over internet or getting data is a kind of luxury. And luxury is not something on the bet of which, I hope you believe, right? I hope you believe. Luxury, I hope you believe luxury is not something, you see, it's very general. Luxury can become a need. Like smartphones, when it came into market, smartphones were touchscreen luxury. And slowly, with the transformation of its application, it became a need. Like we don't need only smartphone for touchscreen part. We use that for a lot of other purposes. So luxury is going to become need. But behind that particular curtain, there is a big market for these companies. Why they are providing this sort of IoT related applications? Because they want to create data. They want to get data from the customers. They can make use of it, do predictive analysis, as into previous particular Mr. Surgeon said about predictive analysis, which is also one of the biggest reason about the push to IoT related applications. So these are the reason why most of the industries are moving towards this. Now, talking about our current IT structure, what we do is like we design ERP, CRM portals and automation stuff. Like we design information automation, easy accessibility, easy data storage sort of stuff. We design for offline companies. Like what we do into IT companies is we do serve known in IT clients. Now, when those known IT clients are going to make use of, they want to use of data-driven model of business, they're going to involve IoT related stuff into their particular business or products. Who will be serving them? Who will be serving them? So this shows that in very short span of time, most of the current flavor of IT projects that we are getting are going to be transformed, are going to be more things related. So it's not something that how a user feels with only interface of Android app. Also, it also depends that how that Android app is easily connected with a thing or device or machine to which it is going to be integrated. Okay, so it's you can say the domain is going to become more broader. Right. So this is just one aspect why industries want that. Now again, another use case. So there are a couple of use cases of IoT, and I hope this is a sort of prediction. I bet that you would have already seen similar prediction by Gartner, McKinsey, Cisco, Ericsson, that we're going to have around 40 to 80 billion devices by 2020. A lot of prediction you want to see, but I don't want to believe. I mean, you can believe on these predictions, but not mine. So just what we are trying to do is we are trying to understand what are the reasons behind this. Okay, so that, as I said, IoT is not only limited to the luxurious stuff and controlling your appliances part. It's like big faces why these companies are involved. One thing is there that providing better user experience. If somebody does not provide a better user experience, they're going to be wiped out on the market. So that is there. But other than that, backing up, a big reason is data model of business. Another reason. So you see a couple of applications from IoT if we talk about. So that requires industrial IoT. Well, you see, we are talking about technology, and technology is making us a bit trouble. You see, again, now, well, that's great. We have technology helped us quickly. All right. So another application is government. You see, not only government, the management would be a better word. As let's talk about cities. As the population in the cities, the density is going to increase day by day. A lot of every day, a lot of buildings and flats are coming up. Societies are going to are getting added up. Roads are being built up. Just let's talk about a simple scenario of roads. Every day, Indian government into developed cities building a lot of roads. Now, all those roads will require street lights. Now, maintenance of those street lights, they cannot simply deploy the street lights and forget about them. They'll have to do maintenance of that. Now, as soon as number of street lights are increasing, it's very hectic and complex task of involving human resources in analyzing all the street lights. Do you believe? I mean, you agree, right? Now, what do you need? You need a smarter technology which can actually do this task very easily with capable or the available, because you see, these things are going to be expanding day by day. So every day you cannot increase human resources who are going to analyze the street light fault and understand that, repair that part. So in cities, when cities are expanding, the government, the way the government is going to do management, that has to be transformed, and that is in fact being transformed. That is in fact like Indian cities who are already started up working with smart grid management, in which they are trying to manage the power distribution into different cities and villages. In the festival time, the industries are off, so that sort of power could be smartly distributed to village area where they can enjoy with the festival part. So smart grid management is like in India, it's quite quickly started up. So when the cities are going to expand to manage the services, not only this like street light part, you would have, if you have been to Barcelona, you would have seen that smart parking management system. Into that, like Cisco does that part management. So what Cisco analyzed is like in Barcelona, people do own their car. So when they go from one part of the city to another part of the city, probably you might not know where to park your car. So what you do is you slow down your car and search for parking spaces in and around. That's what you do. And let's say there are more number of people who are driving cars. So if they are going to slow down, so a huge amount of short span traffic was caused by the people searching for parking spaces. And Cisco analyzed that around 40% of the short span traffic in the peak time was caused by people searching for parking spaces. And now what they did, a solution to that is they connected sort of sensors to each in parking spaces, collected data from them to the city traffic monitoring server, created mobile application app, so that I being a user, if I want to drive my car and park my car, and just click on park now, they locate it. My Android phone or the iOS phone will locate my location, connect to the server, find out the nearest parking space where it is empty available. I can go and park my car. So they simply made a parking lot connect to internet, talk to internet, and tell that whether I'm empty or I'm filled. Now this is the big picture of IoT, which is behind this smart connectivity. Probably all of you, a lot of you might be already pretty aware about this, but this is what I wanted to involve in, because I have seen a lot of people who actually think that this is it. I mean, the IoT is all about controlling your appliances. Well, that's just one part of IoT, which comes under the consumer IoT. We talk about smartphone related stuff, wearable gadgets, smart shoes, smart TV, applications, smart home related stuff. But bigger than that, this, you see, in India, consumer IoT is one of the growing thing. One of the fastest growing market in IoT market is consumer IoT. But one of the most contributing market to the economy or to the complete IoT economy is industrial IoT and then government IoT part, which is quite of much not visible. Okay. So when we talk about testing and challenges, we'll have to take the stuff from all of them three. Okay. Like Sajjan was talking about, in the panel discussion, what they did is like they simply connected the textile machines to, created data from them and analyze that when it's going to be damage or failure detection, which is what we call predictive maintenance. Okay. Fortunately, like I'm from Surat and my father is into textile industry, so I have seen what he used to tell me, like in past 5 years, the transformations of change machines he has seen in his industry. So previously it was a fault, so they used to spend around hours and hours to find out the fault, where is the fault is coming in saris and why that particular miscolor or light color or very dark color is happening, which was a big challenge. Again, if there is a dark color and the client wants a light color of saris, so you will have to again do a lot of stuff on those saris, which will again degrade the quality of the cloth. So it was a big problem for them to find out the faults into textile industries. IoT is all about making things create data. So what they did is like, companies, probably the client of Surgeon, would have done that, KPIT, like connecting a lot of sensors to your machines, let them create data about what is happening in real-time data about. Okay, get the data. Once you get the data, then it comes the role of big data, and then it comes the role of machine learning. You do the predictive analysis, build the models, which do the prediction. So backed by IoT, making your machines, things connect to internet. So that's part of industrial IoT. You industrialize things, which is what digitalization is. So we at Anvay are also into sort of digitalization of small things. Now we don't do big things, we do small things. Digitalize small applications. Okay, so this is the big picture of IoT, which is all about the making things connect to internet, create data. All right. Then it comes to you make use of data and do anything what. All right, that's the another layer of it. So is it that so easy to connect things to internet? Well, at this point of time, we don't know what are the challenges. So that is my main point, like being a quality testing person, what are the challenges and what should be the preference, what should not be the preference when it comes to connecting things to internet? Well, okay. So the first point is, when you talk about the current set of devices, machines, gadgets we have heavy machines, like we have PCs, computers, which has RAM in terms of 4 GB, 10 GB and all those stuff, not 10 GB, 8 GB, and processing speed up to gigahertz, and sort of a good infrastructure we carry, even if it is smartphone or tablet as well. But if we talk about small things, let's talk about your home automation, even your tube light, you cannot attach 4 GB RAM with your tube light or 1 GB RAM. So what you can do is, you're going to attach a small computer, small programmable system, which is going to have around RAM of 1 KB, 2 KB probably, or 5 KB, 10 KB RAM, or around 1 MB of flash memory, hard disk, or sort of megahertz speed of processing speed. Small computer. So IoT is all about a trillion small things. Let them create data, connect data. The way this, the big infrastructural things used to create, like computer, smartphone, servers, and tablets. Now, what is the difference from IT to IoT part is, when we talk about servers, computers, smartphones, we don't care about how much power it consumes. We charge them regularly. Servers are always powered up. We don't care about how much infrastructure you require. What we care about is, I want my YouTube video to go very quick. Okay. What you care about is the reliability. All right. When it comes to IoT devices, you cannot let the devices, machines consume as much as power as these devices consume. You can, in fact, in consumer IoT, how many of you can afford more chargeable devices to which you need to charge every day? You always carry, you're already carrying up laptops and smartphones, tablets as well. We cannot afford that in consumer IoT. In the same way, we cannot afford that into industrial IoT or government IoT. If we cannot afford every street light, if it is connected to internet, to consume double amount of power. So power consumption is a big challenge. So that is going to again transform the type of infrastructure we're using in IT part to the type of infra that you're using in IoT part. The amount of RAM, amount of the type of protocol, even we use HTTP protocol to connect data and all those stuff. Get and post request. Not at all a suitable protocol when it comes to IoT part. Very heavy HTTP is, slow it is, and high power consuming it is. Not at all recommended. So this is how the things which are currently the part of infrastructure of IT world are going to be transformed into IoT world. So tomorrow when you're going to get a lot of IoT related projects, you need to check that are those particular things being used over here or not. So first comes the power consumption. When it comes to power consumption, you need to take care about how much is the power consumption of the device, machine, or particular sensor attached to that. And when it comes to IT world, the protocol that you're using, like HTTP consumes high power. What is the solution? You could use MQTT protocol, CoAP protocol. Now, is it that easy? Again, security comes into picture because we already have the security for HTTP and similar port number 8443 built up. Our systems are very much secure to 443 and all. Now, pouring a new hole for MQTT of 1883 into the system is going to be a big challenge. Okay, if that is made, let's say that your server is made to support MQTT protocol. Now, what are the challenges of security that yes, 1883 is being not, I mean, you need to do testing of 1883 part. What are the different ways of how do you access 1883 protocol or 5683, 5684, like CoAP and MQTT protocol, whatever you use. All right, so what kind of infrastructure that you are using, is it that suitable to the consumer support? Because a consumer cannot or a client cannot afford more power chargeable device. This is a very basic and one of the preferred requirement when it comes to IoT part. Second, security. Like a lot of people Rizwan has already discussed about security, but what is that? We know that yes, everything is unsecure. I mean, IoT is going to be a big challenge when it comes to security, but how do you tackle that? How do you solve the problem? Or why is that problem occurring up? Because banks are secure, the financial transactions are secure, why not IoT? Okay, I guess there's nothing more important than financial transaction, right? When it comes to security. When banks and financial transactions are secure, why not IoT? Why can't IoT be? It can be. But why not it is? So if you talk about in India or most of the developing countries, the market of IoT is what? Not very quickly growing. So there are a lot of vendors, small scale companies which are manufacturing a lot of stuff which are much more IoT related or smart products, but they are not or they do not care about the security into that. Why? Because if they put a different team into security analysis and all, that's going to increase the production cost, and at the end of the day, the product is not going to be sold in the market. As the rate of adoption is not so good, the revenue generation is not so good, and that consequently hampers the effort that the manufacturer is putting into that to make it secure. Okay, so it will take in India time. Now again, this challenge has to be addressed. You have to put it some sort of measures so that again the manufacturing cost has to be again managed and it has to be secure. For example, you would have seen that basically just a year back, whatever the routers we used to purchase, all of them used to have the password and username admin. That was a very basic stuff. The manufacturers don't care about what admin and people. And I guess I didn't even change 3 years back when I came across one of the attack that was made on Twitter and similar servers just by accessing all the routers of the world, which are having password admin. Because you see, routers are the outermost layer, device layer, which is connected to internet. And if the password is admin, it could be easily accessed and could be used to make DDoS attacks. So as many as IoT devices are connecting to internet, you have that many devices which are going to be usable or easy potential user to make DDoS attacks. DDoS attack is simply making your computer send unnecessary traffic to somebody else. Now, our computers do have firewall, our computers do have antivirus. Do we put antivirus in small chip? We don't do that. Now, if those authentication are unsecure, why people will talk about and why somebody will try to hack your computer? Somebody can easily try to hack your IoT device and let it send the traffic. And there are multiple of them. Authentication is one of the things that has to be checked out, proper authentication, which is what most of the manufacturers do not currently keep in mind while making it manufacturing device. Another thing is what? Why our computers and smartphones are so secure, at least secure enough, is because we have operating system into that. And those operating systems are quite built up. I mean, quite good. If we talk about Windows, the Microsoft spends a lot of money into making the firewall of our Windows OS quite good, so that it cannot be accessed by somebody stranger, or you can say anonymous. Now, when you talk about Microsoft OS, we have Windows OS in our system, which is quite big in size, and I mean in size when you talk about the RAM and all those stuff could be embedded in that. When you talk about a small device in a smartwatch, can I build a Microsoft OS? I cannot do that because it requires heavy infra. Okay, so most of the IoT devices that you will find, they do not have operating system, or there are no compatible operating system available for them. Now, coming up as IoT is developing, technology is developing, we have RIoT, Contiki, Embed. These are small operating systems which also run on the 1 KB, 2 KB of RAM as well. Now, while first thing that yes, if you are into testing team, if you are into IoT related project, you should check that at least your device should have OS. It should not be deployed without OS. The same thing can be done with OS also, without OS also. With OS, what are the benefits? That yes, the OS provider would have built some sort of firmware and some sort of firewall in that. Another benefit is what? If like let's talk about Windows OS. So we don't care about the security part much. Why? Because Microsoft cares about that. Microsoft keeps on putting updates on our OS operating system regularly. So if you use operating system into your IoT device, it's going to be the provider is going to put a lot of updates of bugs which are possible, and so you can stay a bit cool. You can say taking a bit less care about security part of it. So operating system is required. Again, which operating system you use, that has to be also taken care of from a lot of available offerings. Then the third important part in security which comes up, on-air updates. Our smartphone and our PCs do have on-air updates. So you have to check the software, the stuff that you're using, the programming language even you're using, are they so active so that they are putting up quick updates on the bug possible into them, regular updates. If that is not possible, your device is gonna, let's say that a new update comes up and your device is not compatible to that update, everybody will have the potential device that this can be easily hacked. Okay, so when it comes to security part, there are a couple of measures we can take care of it. All right, and again, power consumption, as I said, reliability is another important factor, which can be compromised in some cases, and again, some other stuff can be put up to more priority. Okay, for example, well, I'm going without slides. Let me actually go with slides. Okay, so challenge in testing includes, when it comes to most importantly IoT testing, just not find the bugs, prevent them. All right, so before using building the system, you should check with that operating systems and all those stuff we are using, proper security you are using. So just don't find them, prevent them, so that bugs do not comes into the picture. Or you have certain silent mode in which everything will be updated from the provider and you don't need to put much of your yourself into securing stuff. Okay, now another point is what? Right now we have sort of people, let's say that IoT is kind of combination of hardware plus cloud, right? I hope you agree. Okay, now when it comes to the professionals or experts, so people who are into IT, they are much more stick to IT. Yes, I know cloud, I know networking, I know application development, I know web development, I don't know about the hardware part. People who are into hardware, they are very much separated from the IT part. This is a big gap into industry where a quality testing expert or QA person has to fill the gap and is having more opportunity, the integration part, because both of them are going to lag in each other integration part. This is the biggest gap into industry where IoT and most importantly for a QA expert is having the biggest opportunity, the integration part. You need to have the domain knowledge about the hardware part along with the domain knowledge. You don't need to be a coder into that. You need to have domain knowledge about both of them, so that when it comes to integration part, when it comes to the getting data from cloud to the device from the data cloud, it's going to be you are the one who is going to be solving that challenge. As in the panel discussion also, one of the experts discussed that there were 5 machines, but all of them machines from same manufacturers were creating different type of data. If you don't have knowledge from the hardware part, you won't be, the IT person who is actually analyzing the data and building the big data solutions won't be able to analyze that part, because he is pretty much separated from your hardware part, but you are the one who need to play the role into that particular integration. Okay, again, integration has to be what people try to do is like, let's make device consume or have 10 KB of RAM, or let's say 20 MB of RAM, and let's use STT with the traditional stuff that you are using, and let's make the system okay. This is what when it comes to developer, I have been also into that particular stuff. What we try to do is like we try to make it happen anyhow. That's our main objective. Try to make things happen on the time. We don't care about things. Now again, when it comes to, because both the parties are going to have limited alternate domain knowledge. So here the role of quality QA expert comes up. Oh, I'm changing the slides unknowingly. All right, so again, testers with domain knowledge, multi-user application, distributed environment deployment. This is pretty important part. Now you see, when it comes to deployment part, the traditional stuff which we used to deploy, like your website is going to run in a browser, nothing more, or you're going to have browser in your smartphone. You just need to make compatibility to smartphone size and the this size particular stuff. When it comes to IoT related application, IoT is going to be deployed in distributed environment. Some hardware part you have, some integration networking part you have, some cloud part, some front end part you have. A lot of different environment, and that too again different places. Probably the product, if you are into consumer IoT product part, the product that you're developing might work very well into India, might not work very well into a certain other country or certain other part of India. So that we're coming to that sort of user experience part. So again, security, as we already discussed, the environment is set up so many network protocols. You see, this is pretty important part. Like it's not so simple to connect devices to internet. For example, let us say that I'm having 1,000 street lights on my street to which I have to gather data from them. Okay, I'm having 1,000 street lights from which I have to gather data. So I cannot connect all the 1,000 devices individually to internet. If I do that, it's going to consume huge amount of bandwidth, and I need to provide all of them a separate IP address. Okay, expensive task. What's the solution? Sorry. What's the solution? The solution is like the edge analytics or IoT gateways. Gateway is what? I can have a single gateway which can connect data from multiple devices remotely without using internet, and a gateway can send data to the internet, to the cloud, and analyze it. Now in this gateway building part also, you have a lot of different stuff coming up. Probably like how do we connect with our smartphones and the laptops? We use Wi-Fi, we use Bluetooth. How do we interact with this particular protocol? I mean the nearby devices. If it comes to smart home automation, we are restricted to Wi-Fi and Bluetooth because this is what we carry in our smartphones. When it comes to real-time industry field, on the field you cannot use Wi-Fi and Bluetooth. Why? It has limited range. If there is a device which is deployed in forest or in ocean or somewhere else, it's going to not catch up Wi-Fi and Bluetooth. Limited range. Very expensive protocol, Bluetooth and Wi-Fi, very much power consuming protocols are. What is the new in market? Now you need to be updated with this part. LoRa, Sigfox, and similarly NB-IoT. So LoRa is a free band frequency protocol which does the communication up to 15 kilometers without using internet and consumes only 2.5 ampere of battery for 10 years. Okay, so new things are coming up. When there is a challenge, there is a solution. Now when there are a couple of solutions, you need to choose it. And if you're going to choose it, you need to have knowledge into domain. Okay, so when it comes to real-time field, because you see, most of the type of projects which are going to come up into IoT are going to be from industrial and government domain. And into that, the type of infra that we use, it has a lot of new possibilities, like the wireless communication protocols, LoRa, Sigfox, NB-IoT, again the application layer protocols you talk about, the operating systems, the hardwares, new possibilities are there. Okay, so analyzing that part is pretty important. So we have a lot of protocols, gateways, and networks to carry to analyze them. It was not something that yes, you have single network, Wi-Fi, yes, we are getting data, and TCP SSH client you use, and you fit the data and you get the data from client and you analyze it and done the part. So that was sort of a bit of restricted, a bit of less variation we used to have into the traditional IT stuff, which is going to be pretty much have variation into IoT part. So these are kind of transformations are there from IT to IoT. Okay, and you cannot in general, I mean you can stay up to into particular domain, but again you cannot stay out of it because in any of the field it comes up, like as most of the non-IT clients are going to get transformed. Everybody is digitalizing. All right, so when everybody is digitalizing, most of the projects will involve this kind of certain stuff, and that's the reason when it comes to big data, there was a point of IoT. When it comes to security, the biggest concern like IoT security part. So this is going to touch each and every particular domain or profession, any of the profession you are into. All right, so yeah, so the testing areas includes connectivity testing, compatibility testing, exploratory testing like sort of functional testing, and security testing, performance testing. Sort of this sort of testing areas are there into IoT. What comes into the picture, like in which you need to have you need to grow sort of competency. These are a couple of them. They can be, I mean, functional testing and all. There can be more of them. It just a couple of them I mentioned over here. When it comes to connectivity testing, like easy connectivity should be there. All right. If you see, like there's a big challenge into this part. For example, if I access my email and unfortunately, let's say immediately the internet connection got out, and again I should be able to re-access part. So I should be able to get that part. No, but because again, email is something that only I access. So somebody else is not going to access, or some device is not going to access. Or let me give you a better example, a transparent picture. could be, let us say that yes, I'm having a particular simple example. The more famous one is I'm having a bulb which is connected to internet, right? And I am trying to access it. Now I'm somewhere outside and I do not know that there is issue with internet connection with the bulb part. I do not know of it. I try to control it. I try to switch on off it because I need to do timely maintenance of it, or I need to control it timely. Now, as my bulb is not connected to internet and I do not know whether it is connected to internet or not, I can simply send the data. Now, that's going to create a problem. And I cannot always stay actively waiting that when my bulb is connected to internet, I will switch it off. I cannot actively wait for that. So, connectivity is a big issue. Now, Amazon's AWS IoT stuff, they solve this issue with a very, MQTT protocol also addresses this issue. Like in AWS IoT part, what they have is like they have a device shadow. So, any device you connect to internet, a dummy copy of that device is going to be generated in the cloud. So when you interact with the user interface, you interact with the dummy copy. So if I want to switch off my light, what I will do is I'll send the connection to my dummy copy. My dummy copy will send it to original device. So in some cases, my original device is inactive. It's off. I need not to worry about it. I need to simply send control to my dummy copy. As soon as it comes into connection, my shadow will update it. My dummy copy of the device will update it. So there can be a lot of options. How can you address the issue of connectivity? Because your devices, machines, when it comes to IoT, are not going to be always connected to internet, are not going to have easy connectivity part. Again, if it loses connection, so it should have capability of re-registering itself and getting into that securely. All right, so certificate authentication, SSL, TLS sort of stuff, again, security part should be used, and again, the connectivity should be simple, and you can say it should be seamless, easy connected registration of devices, re-registration of devices should be possible. All right, then it comes the performance testing, like how is good device-to-device communication, how quick it is. Okay, like again here you when it comes to latency, okay, and when it comes to quickness of the machine-to-machine communication, and again at that particular point of time, you don't want to make use of heavy stuff. You want the communication to go very quick. You don't want to use much bandwidth. You don't want to use much heavy processing system. Okay, it's like what if I use RAM of 8 GB and all those stuff infrastructure good, I can have good speed of communication between devices, but I don't want to use that. Again, at the same time, I want quick communication between devices. So what are the possibilities? Like you might use sort of lightweight protocol, let's say connection-less protocol, asynchronous protocols, UDP sort of oriented, device to server, server to server, when it is heavy data you have on the one server. So how do you transfer that part? Okay, and network bandwidth, latency, packet loss, or certain reattempt of sending data packet. So that sort of challenges has to be addressed. Again, you have to test this on a long-term environment and then analyze data of it. Analyze the performance of it. Okay, then similarly, like we have the user experience, like what you design and how user uses it. Okay, and how is it interacting with, like let's say that if I design certain IoT stuff in which you can get the temperature, I can read temperature from my home. How many of you really want to know the temperature at your home? Nobody knows. We don't want to know every time track the temperature. What we want is, if something goes wrong, we want to be alerted. So IoT is all about creating data. Now let's say that your devices are creating data and I as an app developer have put the data in front of the user. Now what user will do with temperature? Is the user going to scan all the temperature values all the time? Not at all. Nobody likes to see the numerical value. Nobody likes to see the data. What we want is result or the alert or the action. The device should tell us what to do. Okay. So what kind of product you are developing and how user is going to interact with that, whether user needs that sort of capability in reality or not. Is it increasing the sort of, you can say, overhead sort of stuff on the user end, like complexity on the user interaction. So that part you already know of it, you have been into UX and UI, probably that's very important part of quality testing. Okay, so that again but again here it comes up like the interaction of user, not only with latency part, like the speed I want, as soon as I click I want to get data on all the stuff, or I should be able to figure out the solutions easily. Again with that, how the device is going to interact with machines and how machines are going to communicate it and how you're going to get data out of it and how you're going to get, build solutions out of it. Okay, for example, let's say that I have a thermostat and probably let's say that I have built a thermostat and which can communicate to my AC and fan, do all the stuff. Now better than this, control them, communicate them. Now better than this, what could be the solution where you can make the user less interact, only take the benefit of it, is like you attach a thermostat outside the home of user window, and if user is sleeping in the night, switching on the AC in the early morning when he's sleeping or she's sleeping late in the morning, the thermostat should be able to figure out the temperature outside, the cleanliness of the freshness of the air. If it is more fresh than inside it, open the window, switch off the AC, and let the user experience fresh air. Okay, so how the user is going to interact with devices, machines is going to be kind of pretty different from the traditional UX stuff which we used to use. Compatibility. Again, like if I'm buying two products from, this is not compatibility, it's like compatibility in machines and protocols. So when I'm buying products from two different manufacturers, let's say that I'm buying a product and you are developing an IoT product for a consumer IoT market, which is going to connect to consumer IoT, consumer device or machine via Wi-Fi. Now all the times our smartphone Wi-Fi is busy in accessing internet. So Wi-Fi should not be a preferred, though Wi-Fi is a very much widely spread protocol, it should not be preferred protocol for home automation or the wearables. What should be preferred is the useless protocol in our smartphone is, or less frequently used protocol, less frequently used protocol is Bluetooth. So what should be the choice? Bluetooth. Or you need to increase something else. Okay. So again, if you're using Bluetooth of Android and iPhone, the device should be compatible to them, or you should have reconfiguration sort of stuff, because both of them are kind of less compatible. So if we are building some stuff, it should be compatible to some other device. Now how do you think? Because how do you select that part? So for selecting any protocol, we should go for standards. Okay, so if you use standard stuff, we are assuming that somebody else also who is manufacturing the product might also be using standard protocols, standard rules, so that it can be easily integrated. Okay, so if you use standard version of Wi-Fi, and smartphone manufacturer also uses standard version of Wi-Fi, so it can be integrated part. Again, so interpretability is a very big challenge and very big thing to be addressed in the market, like how your device is going to be connected up easily. And like Jio is coming up with a particular product in next particular quarter, first or second quarter of 2018, in which they are trying to attach OBD. Our cars manufactured after 2013 do have OBD, onboard diagnostic port. So they're going to attach a sort of product with that, and you're going to easily get analysis of if you are driving your car in high speed, in low gear, sort of stuff. Again, they need to think about compatibility. There are two types of OBD port, OBD1 and OBD2. So they need to release two products. All right. So again, what should be the compatibility? How it is going to interact with the user part? Is every user is going to be able to use that or not? And how they're going to use it with smartphone? So the connectivity should be there. The compatibility between the machines and gadgets should be there. Okay. Security part we already discussed. On-air updates. Hardware security is also one of the biggest challenge. If you talk about smartphones and laptops, you always keep them with you. Okay. So it's pretty easy to secure them physically. But if you talk about IoT devices, we're not going to carry all 10, 20 connected devices always with us. We're going to put them somewhere remotely. Now, when a device is there at a remote location, anybody can hamper the hardware infra of device and get the data from it. Okay. So that's pretty easy. So again, your device should be packed in such a manner so that it could not be easily deassembled. If it is being deassembled in such a manner, it should be deactivated immediately. Okay, or some notification should be prompted up. All the accessibility should be banned. Rules should have been need to be designed, and things to have. Again, one of the I have been to one of the previous conference where I was fortunate to meet one of the team from Murata, and what they are dealing into hardware part security is, like, again, we humans do carry our laptops and smartphones. So what is even possible in hardware insecurity is, like, the process which occurs, the program which runs in the backend, it runs in the form of ones and zeros, and every ones and zeros generates certain different pattern of voltage being consumed. So if somebody can only read from where you are powering the device, the pattern how your device is consuming power, easily the program can be decoded, and it can be hampered up. All right, or just by hampering the amount of power consumption, the device functionality could be changed. So again, the power consumption is also being decoded in very, very important health devices. For example, if you're designing some IoT devices for healthcare, so their security and reliability is the biggest concern. Power consumption might not be a concern. Okay, so it depends, again, different use cases, different environment. You need to check with this part. All right, so these are a couple of channels. Do we have more time here? Where is? We have more time. 5 minutes more. Okay. All right. So this is it. So let me know if you have any questions so far, everyone. Like, we have sort of strategies should be easy detection of the device, because security is something that you can let the device get manufactured and then you can think about security part. But again, if it comes to the testing part, you cannot let the complete system build and then you think about testing part. So it has to be like, that's what agile process we talk about. All right, so that's not something very new. Virtualization of IoT devices is pretty important. Like virtualization of the software stuff, we already have VM stuff. We can create a virtual network environment, deploy the system, test it, and then build it and deploy it. But again, IoT devices virtual infrastructure building up is again a big challenge. So building the virtual environment for IoT use cases is also very important when it comes to testing it before deploying it off the field. Remote testing. One of the NXP was there into that sort of conference. So one of the client of NXP was having issue that they deployed. They were having in India different cities 500 certain sort of devices which used to do a particular work, and now they were using certain sort of frequency which was a licensed frequency, licensed spectrum. So in 2015, government changed certain sort of rules and they released that licensed spectrum and they made it, they kept it in certain different part, and they needed to change all systems immediately. Now it was a big challenge for them because again going into all the 500 locations, changing the firmware, changing the device, the program and everything and some sort of hardware as well was a big challenge. Now when it comes to firmware part, your devices should have that same own air updates, like you can update them all remotely when you find out certain sort of bugs, okay, rather than manually changing them up, because the devices are going to be very huge in quantity. It's like website, you have one, and one website is going to be accessed by different people, right? Or one software is going to be accessed by different people. But IoT devices, number. And when they have numbers, in numbers, the software is uploaded. You need to be you can say remote testing and sort of stuff should be available. So these are a couple of stuff. Now let me know if we have certain questions. I hope I was not so quick. I have a bad habit of speaking a bit quick. So please let me know if I missed something or you want me to repeat certain part, or if you have any question so far. Yeah, please.
If you are working on an end-to-end IT product.
You are not actually audible a bit. Okay.
Which software we will use for IoT testing? If we are working on end-to-end IoT product, from back-end to front-end, from sensor data to gateway to mobile, device to device to server, and server to server communication. So which software we will use for data testing? From sensor to gateway, how will we verify that our data from sensor means temperature is 34 and we will get the exact accurate temperature at gateway. So how we will verify and how we will test this data? Which software will we use for this data testing?
You see, the very first point is, as IoT is sort of integration of technology, so at every level you have different technology working. For example, in hardware you have embedded C sort of code working up. In network programming you have different sort of programming. In cloud you have different infrastructure on which the cloud is built up. Okay, so again, like at every level there has to be different specialization into testing. If your client is using, let's say, a particular IoT platform, for example, ThingWorks by PTC, it's an end-to-end deployment platform. Okay, so ThingWorks, like again, people use different stuff. So let's say that if I talk about cloud, now I get sort of good competency on the cloud when I use IBM Bluemix, because Bluemix has a lot of good services available. So I'm using Bluemix Cloud, and at the end hardware part I'm using Interprocessor. Into that I'm running the C programs. When it comes to integration part, the protocols, I'm using Python programming that. So again, different level you need to work with that. If it is advisable for industries, industries also do prefer that. ThingWorks is quite trendy because of end-to-end solution. So that sort of stuff can be used. If it is a single platform is integrated for end-to-end part, ThingWorks, Zivli are the couple of platforms which are preferred for this. If again your system need to be built up on the top of it.
Like we are, many people are uses Wireshark software for testing data on Wi-Fi network. If I am using any hardware which is connected to my Wi-Fi network, and I will test the data using Wireshark. So same tools are available for IoT testing.
You see, like Wireshark is for Wi-Fi. Now in IoT, now this is a different layer protocol when it comes to, there are different layers into OSI model, right? You have hardware layer, you have communication layer protocols, then you have software layer protocols like TCP, UDP comes into transport layer, and application layer protocol like HTTP, and different protocols, and cloud layer. Now this Wireshark we use for Wi-Fi part. So similarly, what are the alternative like LoRa and Sigfox and this NB-IoT and all those stuff, like NFCs are alternatives part. So for them we have tools for testing this stuff. But again, different. There is no a single tool which can do all the stuff end to end. If even ThingWorks does that part, but it does not do in very concrete manner on each and every layer. It gives you the overview of testing part. So every layer, it just as IoT is combination of technology, the testing has to be done in every layer. Like as the previous part, one of the question was like on what should be the thought process and what we should build the competency. So again, IoT is a kind of mixture of, not only IoT, all the projects are going to be a mixture of technologies. So you usually need to fix couple of layers or one layer or two layer and build a competency into that. And what is more advisable is the integration of both the stuff when it comes to IoT part specifically. I hope that answers your question. Yeah. Yes, please, everyone. Do we have any other question?
Are there international standards for IoT at different layers,
Yeah.
device level, networking level, integration level? So standards are there?
Yeah, they are. You see,
Are they mandatory?
Not mandatory. It's like, but you should use them. One, you see, like at every layer we have standards. Like hardware layer, again, like standard manufacturers are there. They are standard manufacturers. Like Intel is a standard manufacturer. When it comes to, let's say, that communication layer, so LoRa is built upon a particular standard, and all the protocols are built upon a particular standard. They support a standard, and when we use that particular module, so we should follow that standard. The reason is, if that standard is having certain sort of rule, it was already tested if something has to be changed into that. And again, if it comes to connectivity, interpretability with some certain other devices. So if we use standard, somebody also is using standard, it can be integrated easily. So it is advisable to use standard. If we don't use, again, probably you're going to end up being into the water alone, and everybody has gone out of the water when it comes to flood. Okay.
Yeah.
Yep.
Hello.
Yeah.
Yeah. How the site, how the performance testing is being done for the IoT devices, because there will be multiple layers involved and total end-to-end flow will not be possible. I think the polling will be there for each and every layer. So how it is being done, using stubs or?
Yeah, you see, talking about performance of an IoT solution or a system, now how do you measure the performance? That changes case to case. Like for example, like as I discussed, couple of performance measure or the priorities when selecting a lot of stuff could be what? You want least power consumption, you want high latency, or latency could be adjusted, or you want high security. For example, let us say that when it comes to getting temperature data from my home or from my machine, now let us say that my machine is sending data every 5 minutes. At 12:05 I received data, at 12:10 I received, at 12:15 I received, at 12:20 I did not receive the data, 12:25 I received. So every one packet out of, every one instance out of 10 instances missing, that's not a big deal, right? It can be managed. So here you can say the reliability is should not be a performance measure. What should be? Like I do not want it to consume more power or more bandwidth. So when it comes to performance measure, you have certain sort of parameters like power consumption, latency, security, reliability. Now these has to be considered, these has to be analyzed on a whole end-to-end part. Again, the level, you can say the priority of all of these can go up and down depending on case to case. Okay, healthcare has different priorities like compared to the, you talk about consumer IoT, industrial IoT has different priorities. Again, like if it is oil and gas, if it is, let's say, sort of manufacturing, or if it is process industry, different priorities.
Okay, I have another question related to this. The answer which I gave is more towards the client-side experience. When it comes to the server side, when all of the services are being accessed from a centralized server where this IoT is being hosted, maybe we may encounter different protocols are being used by different devices in terms of the IoT protocols. And the SLAs in the performance terms from the server side would also be differ. So how that we can manage when we will be testing a particular device, say I need to switch off my AC, but from end user point of I can see the SLA, but at the server side how it would be done?
Yeah, you see, like again, how do, the question is like, let me know if I correctly repeat your question. The question is part like at the end user part, we know that probably like how we want to interact with the system, how we want to connect it with that. But the server side, when it comes to the complexity of different verticals in IoT, different types of devices, different types of protocols, different types of sensor data, and different types of connection, and the huge number of connections, how that gonna be handled? I guess, is that right? So again, when it comes to this part, there are couple of solutions to this. One of the solution, what industry generally go ahead for is generally we do cloud computing, we do handle most of the data directly on cloud. Another is we do edge computing and fog computing, we call it. Rather than getting all the devices directly connected to cloud, we let the devices, let's say that if it is industry and I'm having 100 or 1,000 devices deployed over there, rather than let them all connect data individually to cloud, or let them create data from them at a single node or gateway and then send the gateway to the cloud. So on behalf of 1,000 requests, 1,000 different protocols, I'll have a single protocol. Okay, so edge computing or gateway computing is one of the solution. Another is the IoT compatible protocols are pretty much good, which addresses this issue. For example, let's say that when it comes to HTTP, the traditional stuff that we use, it's we need to have a server and we need to have a client. We send data to the server and server is going to process that and send reply to us. And when it comes to the IoT protocol, you deploy a broker in the cloud, MQTT broker. So broker never does the processing part. It never understands the data. It never does that part. It simply gets the data and filters and sends it back to that. So we have machine-to-machine communication, easy infrastructure available on the cloud. I mean, in the IoT part, which makes this stuff quite easy, and you can say less complex. Again, there is going to be complexity because you have at the end you need to accommodate MQTT, HTTP, WebSockets, COAP, of them. I mean, COAP can be again transformed to another protocol. You need to accommodate that part, but a lot of complexity can be you can say broken down by using the techniques like gateways, edge computing, and the protocols like MQTT, which is going to easily handle the multiple n number of machine-to-machine communications on different topics. Okay, so that handles that part. And other than that, protocol transformation, protocol you can say translation, DDS, data distribution service, that also does this part. You can use DDS between multiple protocols, which does this part. But again, most of the cloud servers, if you talk about the established IoT cloud servers, Azure IoT Hub and AWS IoT Cloud, IBM Watson IoT, they do support MQTT and they do support into the end device integration part, because at the end of the day, you want to get data insights from all the devices. You don't want them to work everything all together on the ground. So when it comes to the capability, how capable you are in controlling and accessing data and insights out of your machine or system which is working on the ground, you need to increase this complexity on the ground, and that is manageable with this sort of techniques which I discussed. I hope this answers your question, right?
The last question.
Yeah. Okay, last question, please. Yes. Yeah.
I would like to ask one question. So, we are discussing about idea, and what I have understood from IoT Internet of Things, it has sensor, hardware, and a small bit of software. So, we are discussing about machine-to-machine communication, where, like we also want to describe, etc. But if I want to put this in the real world scenario, for example, if I want to sense something and take images based on those. For example, I want to sense that food is steak, and I then want to send a message that okay, I have been told steak food. Can that be done with Internet of Things?
Yeah, I mean, you want to get data from the device and send data back to the device.
Yeah, but what I mean to say is that can we have sensors or can we have Internet of Things around sensing of behavior where I can smell something, where I can see something, and then
You see, one of the main idea of IoT comes into picture. Why? As I said, let the devices create data. When you talk about devices create data, who creates data? Sensors are the most important points into the IoT ecosystem, which are the data generation point. So in our case, we humans create data about what we are interested into. How our devices do not think, right? So they do have accommodated sensors. So sensors are already one of the pretty integrated part of the machines and IoT ecosystem, which are data generating points. Okay, so it's when we talk about IoT, it's like what we want to get data insights from. For example, if I want to control my fan, how do I know I want to switch off my fan, on my fan, or what I want to do? It's I need to have data about my room environment, whether it is cool or not. Let's say that I am talking about an Uber app, which is via which I am traveling to my home. So I want my Uber app to cool down as soon as I book my cab and I'm about to reach my home. I want my room to be cooled down, my AC to be already switched on. So there has to be sensors on the room which can send data to cloud, and again that can communicate with my smartphone Uber app and tell it as soon as my Uber app is approaching the room, it can simply switch off, switch on the AC and cool down the room. So sensors are already integrated part of IoT, and it can be easily integrated. And when you talk about data communication, what is the data? The data is two types. One is what sensors data from input devices, which is what generated by devices and machines. Second is what we generate data about the devices to which we want, how we want to control them and what we want to tell them. like that.
Maybe like my question is this way.
Sorry.
We have sensors.
Huh.
I do understand it. But now I want to develop something where I can my own senses, human senses. So human senses is one of smelling. Okay, so I can smell something, process that thing using deep learning or machine learning, and they then take a decision and then send
Back to the device.
back to the device. Then
Yeah, that's what we call predictive analysis. That's what we call predictive analysis. It's happening. I mean, when in panel discussion, I was discussing about textile industry. What they do is like they connected a lot of sensors into machines, collect data from them, analyze what are the advanced signs. For example, let us say that every day what we do is every day when I go travel, I take my car. Every day I need to check what is the air pressure in my car. Okay, all the tubes. Now, if I can connect sensors to all of them, let them create data, generate data on the cloud or in the particular local gateway. All right. Once data is generated from previous 1,000 days and how many kilometers, when this was the air pressure, how many kilometers it can go every day, simple machine learning algorithm, predictive algorithm could be built up which can then do the prediction after 1,000 days that if you have this much of air pressure, this many kilometers your car can go. Okay, so predictive analysis is all about making things communicate intelligently to things, machines to machine, and adding intelligence to that. That's what we talk about predictive analysis. So with this part, we're ending up. I hope I could answer all the questions properly. Thank you very much, everyone.